On the bench today, we have a Lafayette Telsat SSB 100. Everything seems to work on this radio. The guy sent it in to have it VFO installed. So we got to check to see where we can inject our signal, whether we can go right directly in where a crystal was, or a crystal is, and see what frequency we have to have and what signal strength is required. Well, let's see what we can find out. Now, we're on channel 1, and we've got 3 different hookups here. 3 different coaxial hookups here. So let's take a look. Alright. On this one we have about 280 millivolts peak to peak. Let's see here, and we're at 237 2 per megahertz. But that's on AM. Let's switch to upper. You see it goes to 239. And then you go to lower, it goes completely dead. So it's pulling its lower sideband frequency from a different area. So we can't use that one. Okay, let's go to this one. This one's our 14 megahertz. And so we're still on channel 1, AM. Okay, we just switched to KCs up, and then lower sideband, no change. And 2 KCs down on AM. We can't use that either, because that's our 14 megahertz mix. So we need to come over here to our 23 megahertz, and let me get hooked on here. There we go. Okay, we have our 23 megahertz crystal. That's still on channel 1. There's AM. There's upper sideband. There's lower sideband. Okay, see, the frequency stayed the same. The amplitude changed. When we went to lower sideband, it dropped to just about a volt, a little over 1.1 volts peak to peak. Upper sideband is 1.2 volts peak to peak, and AM is 1.2. Okay, so we can use our 23 megahertz crystal, our channel 1 crystal, and hook the VCO in there. But now we need to see if our VCO is putting out approximately 1.2 volts peak to peak. Okay, according to the schematic here, our lowest 23 megahertz crystal is 23.330. So we need to set our VFO frequency to be 23.33. Alright, let's go ahead and do that and check the signal strength out of the VFO. Here's the VFO we'll be using. I will be showing more about this VFO in the future here. But right now I'm going to go ahead and set the frequency and see what our output is. Let's turn it on, and go up here, 100 kilohertz, 1 megahertz. We need 23. Let's go. Zero, 3, and 3. Okay, that should be equivalent to channel 1. And we have 1.2 volts peak to peak. I know that it's a square wave. I know that. That's the output of most of these VFOs like this. These units are square wave. but a lot of the radios will be checking the spectrum on the radio. Once we get the VCO hooked up, we'll take a look at the spectrum and see if we've got any spurious emissions. This is definitely putting out a lot of spikes. So the first, second, third, well, your primary, second, third, fourth, fifth harmonics are definitely spikes with the square wave. Okay, let's see about getting this thing hooked up into the radio. Okay, now I've got my frequency counter offset set. The output frequency of the box is 23.330 megahertz, and I've set my offset of I believe that was 3. Oh boy. Let's see here. 26,965 minus 23.33 equals, yeah, my offset is 3.635 megahertz. So that's what I did, is I set the offset on the frequency counter, and now the frequency counter is reading the correct frequency. Alright, now we'll go to pulling the crystal and install a piece of coax to come out to the VFO box. Got the channel selector out. We're after the crystal. That crystal right there is the one we're after, and you really can't get to it because of this board underneath. So you have to take the channel selector out and unsolder it from the bottom, and then pull the crystal out. It's not exactly the easiest thing to do, because you've got to unbolt the face, take all the knobs off, unbolt the face, unstick the meters from the front face, and then unbolt the channel selector after you pull the channel dial out of it. It's a bit of a chore, but we managed to get it. So let's see if we can get that crystal out of there. Now we need to install a 0.01 capacitor here at the positive side of the crystal, because there's voltage on there. There's about 1.6 volts. We don't want that backing up into the VFO. So we install a capacitor as a DC block. On this particular radio, the Telsat 100, they don't use a tuning capacitor on the 6 main mixed crystals. They count on the other four mixed crystals to tune those in. They have tuning caps on them. So you can solder right directly to ground right at the crystal, put in the cap for DC block, and connect right directly to the center of the coax that you're going to be running out to the VFO. Now the thing is, there's not enough room to get heat shrink in here. So what I'm going to have to do is I'm going to have to take electrical tape. I hate to do that. Just put electrical tape in there, but I'm going to have to put electrical tape in there to keep that from shorting out against anything. Okay, well, now I've got the channel selector back in, and the coax is running underneath the radio. The coax that goes to the VFO. So let me turn this over. It runs underneath here, across, and I have a wire tied down here, coming across, wire tied here, and it comes right out the record jack. And then the connector for the VFO is right here, a little SMA connector and little SMA that connects to the VFO. Now we need to find a place to pick 12 volts. Right now I'm using this cable comes from my power supply to run the VFO. But we want to be able to run the VFO from the radio. So now we need to find where we get a power on for 12 volts. Alright, now we'll check to see where we're getting our 12 volts to run the VFO. Let's throw the meter over here. We'll go sideband here, or I mean ground over here. Turn the radio on, and at the 12 volt plug in the back we get nothing. Okay, so let's check these connectors. We've got 13.5 volts. Okay, let's check it with it off, radio off, and we've got 0. Okay, good. Alright, let's check to make sure in sideband, that was an AM. In sideband we still have 13 volts. The only other thing we need to check is make sure that it has voltage in TX mode. Okay, plug it in and get our ground, and yep, she goes dead in TX mode. Okay, let's check this connector. No, that one doesn't either. Alright, so we need to find a different place to get our 12 volts from. Okay, what's on that connector? Got 13 volts there. And then we've got the 13 volts there. Do we have 13 volts in TX? Grab ground right there. Now that we have the wires hooked up underneath for our voltage supply. Let's check to see if our polarity is correct and make sure that it turns on and off with the power supply. Oh, might help to hook the power up. So there we go. Ground. Positive. We got 13. Let's shut her off. And she goes down to drop down. Turn her back on. And back up 13. Okay, we're good, and our polarity is correct. Alright, let's hook the VFO up and see if everything works okay. Well, there she is, connected up. I'm on 38 right now. And she's receiving just fine. I haven't done any testing yet. She transmits on 38 with no problem. She's receiving. But I haven't done any receiver tests on it yet. No alignments or anything like that yet. But she is working. VFO is working like a charm. Well, we've got it all up and running. I thought I'd show the back here as well. See, I ran the VFO wire through the record jack, the power wire through the PA jack, and so they drilled no holes in the radio whatsoever. So it stayed nice and neat. You just have two wires coming out going to the VFO. Let's bring it back around to the front here. Right now we're on channel 6. And, sorry about the camera. I just hit the camera. Let's take it up to... It's pretty quiet right now. There's 38. It's really quiet. And it should be picking up here shortly because the sun will be coming up. It's about 6 o'clock in the morning. Okay. Let's take a look at the AM audio waveform. And turn it on here. Okay, nice top rounded peaks on top and right down into the valley. She's just a touch over. Okay, let's take a look at the sideband waveform. There's upper sideband. She's rounded over the top and pinched right there in the center. That's a dual tone. That is 2400 hertz and 500 hertz. Let's look at the lower sideband. Same thing. Real decent envelopes. Okay, let's take a look at the receive signals. We're on channel 40. There's minus 102 on AM. Take a look at upper. Change frequency. 27.406 megahertz. And might help. Right there's a minus 112 on upper sideband. Let's go to lower sideband. Change frequency again. 27404. And right at minus 112. So the receiver's doing pretty good. Okay, let's do a bit of a power test here. Channel 40 AM. Dead key of 3.5. Audio. About 19.2 peak to peak. Let's go to upper sideband. Hello. Audio. With a stock mic at about 10 watts. Hello. And about 10 watts on sideband. It needs a heftier microphone. Okay, let's take a look at spikes. Spurious emissions off this radio. Our primary at 38. Our next is 548, but we're at minus 50 dB. That's doing pretty decent. Our next one is at 821 at minus 57. So with the VCO, it's the radio is doing a good job of filtering. Well, we're on channel 38. Listening to 38 lower. It's about common. The only other one I found was 42. But 38 seems to be doing pretty good. The VFO is working really well. You just leave it on channel 1. Well, I hope you learned something. I know I did. And please like and subscribe, and we'll catch you in the next one.